everyone. How are you? Yeah, okay, perfect. Awesome. So are you ready for some fighting? Yes? Okay, so if you're ready for the fights, I think we can start. Let's press the start button. Before that, I'm just to present myself quickly. My name is Henrik Rexed. I am a cloud native advocate working at Dynatrace, and prior to that, that's funny, I updated the slide. Prior to that, I've been working, I'm a CNCF ambassador as well, and prior to that, I've been working 15 plus years as a performance engineer, so testing, breaking, optimizing things, tuning things, at the end, having a lot of fun. And because performance is in my heart, so I try to produce when I have time some content on a YouTube channel, the red logo you see here, PerfBytes. And 3 years ago, I started another YouTube channel called Is It Observable? Just dedicated for observability topics in general. All right, so before we start, I need a disclaimer. So I did a lot of tests, because there's going to be a benchmark behind the scene, and I can guarantee that no birds and no telescope has been harmed during those tests and those benchmarks. So everything is really gentle. Few of them crashed, but they recovered. This presentation is not aimed to blame any of those projects. In the opposite, I'm a big fan of the Fluent Bit community, Fluent community, and on the OpenTelemetry side, it's more about sharing results with the maintainers and the contributors. And also, the idea is that give you some insights on which telemetry agent you should use, depending on your environment, your usage, and so on. So let's start. On the, here on your side, so it's going to be on the left side corner, ladies and gentlemen, I would like to welcome the Ryu from the Fluent Dojo. So Ryu comes from the C background. He's been taught with his big brother called Fluent D. That was a bit heavier for sure, but he was really made himself a name in the logging space. So Fluent Bit was a natural choice on the logging space. And since Fluent Bit 2, Ryu has been trained in also supporting metrics and traces. So he's not only on logging space, he's also doing metrics and traces. And then on the right side corner, we have Ken from the OpenTelemetry Dojo. So OpenTelemetry, I'm pretty sure you know, it's the open standards that has SDK, you can build instrumentation, you can do a lot of things. And there is a specific component within OpenTelemetry that is called the OpenTelemetry Collector that is aimed to basically transport your metrics, your logs, your traces to your backend of your choice. And basically, this collector supports metrics, traces, and logs. So the idea is that here we're going to fight those two agents together and figure out which one is the best. All right. So just so as you know what we're going to touch base here, we're going to go through different areas to fulfill this comparison. So first, going through the design experience, how we can basically going to design those tools. Then we're going to cover the features covered for each individual signal, so log, traces, metrics, and last traces. And then, of course, the really interesting pieces at the end with the benchmarking results. We're going to look at the numbers, the behavior, in terms of CPU resources and memory utilizations. If you're ready, I need your help. I say round one. Yeah, you said design. That would be great. Round one. Ah, perfect, great. Okay, I see that you're following. That's great. So what do we expect from the design perspective? Because it's going to be a log agent, and those log agents will load a pipeline file. And that pipeline file, at the end, is basically defining what we're going to achieve with the data. And each of those agents has, of course, different terminology. So in Fluent Bit, there are 3 sections of plugins. So you have the input, where you're going to define what's going to be incoming in the agent, the parser, and then the filter, and last, the output. In the OpenTelemetry Collector, it's going to be renamed slightly differently. So we have the receiver plugins, the processor plugins, and the exporter plugins. And then you can see the side of that, we have the connectors. Connectors has a specific usage. We'll touch base that on later. It's going to be very useful if you have complex designs. And then we have the purple box here, which is the extensions where you can load extra features in top of our collector. Since Fluent Bit 2, Fluent Bits wanted to be multi-thread, so add more options to process more efficiently the signals coming in. So that's why there is this notion of processors. So in the same thread where you're receiving, you can start processing. And processing means you can start doing parsing or filtering plugins. And you can do the same thing at the output. So before just exporting it to a backend, you can do a final transformation on the same thread. It's very efficient. This is quite new. And if you are using Fluent Bit and you're not aware of that, you should be aware, because at the end, it will change completely the way Fluent Bit is going to parse your data. In terms of design, on the collector side, there's nothing to say. All the plugins and the structure of using the plugins will be the same. Of course, there's specific plugins for each individual signals, but at the end, the design logic is going to be the same. In Fluent Bit, there's a bit difference. The notion of parser and filter is only true from the logging space. So if you're planning to use those sections, make sure it's only for logs, because it doesn't make sense for the others. And that's why the processors that I touched base a few minutes ago is been introduced by Fluent Bit to cover the traces, metrics, and also you can do it on logs. So if you want to pre-process your logs, you can do that using parser plugins if you want in the log pipeline as well. One is important with Fluent Bit is that Fluent Bit has this notion of tagging. So tag is really important to understand, is when you get a source coming in, you will place a tag. So here as an example, I'm reading some logs from Kubernetes, and I'm reaching some kubelet data. So then when the data comes in, I put a tag on that, and then based on the tag, I will say, oh, whatever data comes in, if there is this tag, I will apply the filter. So it's like a if conditions. We can also convert to that. So then you basically, with this notion, with a very straightforward pipeline, with a few lines, you can do very complex things. Saying that, oh, for everything, I will parse that way. Just for the kubelet, I will do this. Just for the logs, I will do that. And then to export, I can do everything in Dynatrace if I want, and just a portion of it to Loki. So you have the options to do that. In the collector, you didn't have that notion until they introduced this notion of connector. And in the connector, there's various plugins, and especially the one called the router connector. And at the end, the router will be like a switch. So you say, oh, I'm doing this, and then I'm sending it to the router, and based on the condition on the data that is in the data, you can say, oh, I'm going to trigger that pipeline. So then you could basically do some complex processing if needed, but you will have to use this routing plugin in that space. On the pipeline structure, Fluent Bit used the TOML format. So TOML, I don't know if you've been aware of this, it's out there, there's a different solution using it. So the notion, you have a section, so here input, say this is going to be input plugin, or this is going to be a filter plugin, and then inside of the section you say, oh, I'm use the tail, here it's going to be the tail plugin that I'm going to use, so I'm reading files. Then I'm using the filter Kubernetes to enrich the metadata. And then you configure the actual plugin. The only thing here I put in red is that you will find in every plugins the notion of tag and match to see where you're going to apply these things. This, if you're using this, you should change. Because since Fluent Bit 2, they introduced this this YAML format, sorry, where in the input you can see there's a parser section. So in the parser section, this is only possible with the YAML file. If you're using TOML, there's no notion of processor, impossible to design. So that's why you put a processor, and then you say, oh, I'm processing, this is logs, and I'm going to do this filter, this parser, whatever you want. So if you want to take advantage of the multi-threading, use the YAML file. On the collector side, it's a bit different. So you can, in Fluent Bit, it's like you define a sequence of tasks. In the collector, it's not like this. It's like first you put the inventory. Oh, I have a list of receiver, I have a list of processor, I have a list of exporters, but there is no logic. You configure them in each sections, and then in the bottom you can see, does it work? Yes, it works. You have a pipeline section, and that pipeline section is you're actually defining what you're going to do. So there's by default 3 pipelines, logs, traces, and metrics. You can have more, of course, to say logs/whatever, traces/whatever. So you can have as many pipelines as you want. But the important thing is here we define, oh, I have receivers. So you list the receivers that will be used in that pipeline. And then you define the sequence. So I'm start with memo limiter. Then I go to Kubernetes attributes. And then I finish with batch. So this is where you define a sequence. So that's the difference between the pipeline logic that you have in the collector and Fluent Bit. So at the end, to conclude, there's no differences. You can achieve very complex things in both tools. It's just that the design will be slightly different. I would say that the collector, at the end, you end up with a huge file, depending what you do, and Fluent Bit will be very smaller compared because it's The way design is different. So no winner in that section for sure. So I think we can move on to the next round. So round 2. Perfect. All right, so login. What do you expect from a logging agent? Well, first, I need to receive the most common protocols that used for logs. So UDP, TCP, Fluent Forward, that has been used quite a lot. It's a Fluent protocol. OpenTelemetry, of course, the open standard, syslog, Kafka, because we use a lot of Kafka queue, and of course, reading a log from a file. And the good news is that those plugins is available on both solutions, so no differences. If you count the number of plugins on the log space, you can say, hey, the collector has more receivers, but who cares? I mean, I have the most things that I need. I don't need this GCP, whatever, logging stuff, because I can grab it directly at the source, so I don't need it. What do we need in terms of actions on the log itself? So we're going to first enrich, because we receive logs. We want to have the right context, because they will end up in the backend. So we need to enrich by adding extra attributes, especially if you're running in Kubernetes, so the Kubernetes metadata. I need to parse the logs. Maybe the logs isn't structured, so I need to structure it a bit. I mean, probably there is a lot of polluted logs. I will drop those logs as well. And then I need to batch them, because otherwise, if I send one log stream by one log stream, I will consume a lot of network for nothing. So in both solution, you have what you need. They're named obviously differently, so that's what we expect. In the parsing section, I would say Fluent Bit, since his reputation, has tons of options. Predefined parser for Nginx, predefined. There is a lot of things. You have WASM plugins. You have many things. In the collector, you have transform using OTTL. So OTTL is the OpenTelemetry Transform language. It's great, but as a design experience, it's easier than Fluent Bit. But that's, again, my opinion. So I would say here in the logging space, you can do both things you can do same things on both tools. It's just that in Fluent Bit, sometimes it's faster. That's, at least for me, at least. So I would say I have a slight preference on Fluent Bit on the logging space. Round 3. All right, cool. All right, so metrics. What do we expect from a metric perspective? So we need, of course, to receive the metrics from the most common protocols. Collect these, that's the OpenTelemetry, be able to scrape metrics or receive metrics from Prometheus, be able to scrape metrics from a host as well. So that is supported on both solutions, no problems. Now, if you move to what we expect from a metric perspective, there are a few things that we need. Of course, enriching the metrics, no surprise. And then there's notion when you deal with the metrics, a metric could be very, very expensive because people tend to say, hey, metric is very cheap. It depends on the cardinality of your metrics. Cardinality is basically the distribution of the labels that you have on a given metrics. So if it's very expensive, then you can say, oh, this label doesn't make sense, I can drop it. So I have the options to reduce the cardinality is really great. Being able to drop, of course, and I'll be able to convert. Why converting? Because remember, there's two formats of metrics in the industry, cumulative and delta. So cumulative is all the Prometheus family, delta is the statsd family, and then the backends that will hold your metrics supports either one or the other. So Datadog, Dynatrace, it's statsd, Prometheus, Grafana is, of course, cumulative. So depending on the backend, you can scrape Prometheus, which is cumulative, and then you will send it to Delta. It doesn't work. You will have to convert it. So conversion is a must-have. So in terms of plugin coverage, the collector has everything. Fluent Bit with Fluent Bit 3, and especially now with the Fluent Bit 3.2 that was released last week, he has the label plugins that will allow you to drop labels, so reduce the cardinality, perfect. Filter, but then there's no way of converting your metrics, which means if you're dealing with metrics and you need to convert it, you will have to go through a collector. So why do I need a Fluent Bit agents where I will anyway use the collector? So metric side, I say clearly for me, the collector. No surprise. Now let's go to round 4. Round 4? All right. Traces. So on the traces side, we want to be able to receive the most common protocols for the traces. Of course, OpenTelemetry, which is the open standard, but there's existent protocols that were out there, Zipkin, OpenCensus, Kafka, because Kafka is always here to store some data. So collector has everything as expected. The Fluent Bit agents on OpenTelemetry support OpenTelemetry only, and with the 3.2 that was released last week, it supports now HTTP and gRPC. Woo! Because before it was only HTTP. Now the plugins, what we expect from the traces perspective, of course, enriching the traces, dropping the traces, and then most over is sampling. Being able to do probabilistic sampling, being able to do tail sampling, it's a must-have, otherwise your agent is just a gateway. So in the traces, because of the design of the collector, yes, you have everything that you need. In the Fluent Bit side, you can enrich, but not with the community's metadata. You can add some extra fields, but there is no way of sampling. So for me, that's clearly, I cannot use Fluent Bit. I mean, just for a gateway perspective, yes, I can use it, but otherwise, I will clearly use the collector because I will have more options with the collector. So collector is going to be the winner in that. Round 5. All right. So to compare those tools, I said, okay, I'm going to do some benchmarks. I want to do pipelines on each solutions just for collecting logs, then collecting logs and traces, and last logs, traces, and metrics. And then I say, okay, so the collectors, there's two ways of designing it, because the receiver in the collector is filelog, which is it used to be an agent called Stanza, and then Stanza has been donated to the OpenTelemetry community. So the filelog receiver is at the end the Stanza agent. So all the processing that was possible with Stanza is always possible in the receiver. So that's why you say, okay, so I can process the log while I'm receiving, and then I can process the log after receiving the collector. So I say, okay, let's try that out. What would be the best way for us? So I did. That's why I have two other pipelines for the collector perspective. And then on the pipeline side, I say from the logs, okay, so I have all the features covered, so I will do complex things, receiving logs, enriching with community's metadata, do some parsing, and then export it with OpenTelemetry. I will enable, of course, on each agent the telemetry, so understand the health of the agents. And then if on the log side, on the traces side, because the limited options with the Fluent Bit, I'm just using it like, whoop, I'm sending the traces. I just enrich with the community's metadata in case of the collector. Add extra metadata in Fluent Bit, and that's it. And on the metric side, I'm scraping a lot of exporter. You will see that. And I do dropping the cardinality. I do a few things. I'm not able to convert, so I will use a collector in the case of Fluent Bit, or the collector will do the conversion. So in the architecture side, so here the QR code to the repo, by the way. On the collector side, I have decided to use the hotel demo, so OpenTelemetry demo, and the hipster shop, well-known demo. Those are there too, because if I stress those applications, they will naturally produce more logs, and they will naturally produce more traces with the load. And then I will deploy, of course, I will have a Kepler, because Kepler is a very expensive exporter, high cardinality metrics. I will use Istio because it provides a lot of exporters everywhere on the cluster, and I will have the kubestack, so kubestat metrics, node exporter, and so on. That's for the metric side. And then from Fluent Bit, I will have a daemon set to read logs, and then I will use the stateful set for the metric conversion. So only for the metrics, the collector we use in the Fluent Bit side. On the collector side, it's the same thing. It's just that I have, you will see that I will have different tests. So I first started with just the daemon set to do everything, metrics, traces, and logs. And you will see that I will change the architecture later on, and you will understand why. So let's have a look at the numbers, starting with the ramp-up test. Ramp-up test means 50 users every 30 minutes on both applications. So at the end, I have 400 users, a lot of traffic. You can see that the load on the log side is increasing on the top graph. And then on the bottom, you have the resources. So on the Fluent Bit consume about 50 megs, 15 megs around that. The collector is about 100 megs. So there is always 80 different megs differences in consumptions. On the CPU side, so this is the numbers of Fluent Bit 3.1, and with 3.2, I am around 30 millicore. 30 millicore. So here it started at 50, and then we jump into 100 millicore, but the collector was consuming more. So we are more around 100 millicore in the case of the collector at the beginning, and then we jump into almost to 200 millicore. So that's for the log side. Now if I introduce the traces, so I just have here the ramp up of the traces coming in. It's basically the same thing. No major differences in terms of memory of resource code usage. Fluent Bit is better in terms of CPU, is better in terms of memory. So no biggest difference. And then I introduced the metrics. And then when I did that, so metrics is quite stable because it doesn't change with the load. But what I started to say, okay, so Fluent Bit is super stable, and the collector, I look at it, oh, the memory is flying on the roof here. That sounds like a memory leak. So let's do a soak test. So soak test, to remember, for those who never done that, we run 24 hours, constant load, and then you measure if the memory is changed. And I did that. And then I say, okay, so a couple of hours, we ran 10 gigs, it crashed. It restarts, 10 gigs, it crashed. So you can see here on the CPU, it tries to clean up the memory. And I say, wow, there's something wrong here. So naturally, I open a ticket, say, oh, there's a memory leak here on the Prometheus receiver, I think. So I say, oh, that sounds weird. What can I do? And then what we did with by looking at the ticket with the community, we say, okay, let's first confirm that it's only the metrics. So I used the same soak test with only logs, same soak test with only traces. No problem. Super stable. So then I said, okay, I'm going to enable the pprof extension. So pprof extensions, it will basically allow you to get a pprof and go routines. So you have an HTTP endpoint to get that. So I was getting that. We analyze it, and we say, oh, the memory leak, in fact, is on the cumulative to delta. And then I said, okay, so converting metrics, you need to have a specific architecture. If you don't pay attention to your architecture, then there's a notion of cache, and then it's mess up, first of all, the conversion, and then you mess up also the cache usage of the collector. So I say, okay, why don't I use, again, a stateful set? So I'm going to use a daemon set for the logs, and a stateful set only for traces and metrics. And I rerun the test with 3.2. No, version, hotel contrib version 0.113, which is the current run. And here it is, 200 megs of memory consumption. So the problem is clearly on how you manage a collector when you deal with metric conversions. So you have different collectors because you have the daemon sets, so the log collections, and the blue one, which is on the top, is the metrics. So I said, okay, great, stateful set, but in Kubernetes, when you have lots of exporters out there, every time you have to go to your pipeline, edit it, add the extra endpoint, add the extra script config. It's a never-ending game. So I think, how can we delegate metric collections? And this is where the OpenTelemetry community introduced a project, has a project called the OpenTelemetry Operator that simplified the instrumentation, the deployments of your collector. And it has a feature called a target allocator. And the target allocator is great. So you have your collector pipeline, so there's a scrape config inside of that. He takes it and says, okay, so I'm going to deploy another workload called the target allocator service. It takes the actual scrape config and then explore the metrics and split it into different jobs. So then he says, okay, how many collectors do you have? Okay, 4. So I'm going to split it equally by 4 jobs for the 4 collectors. And then at the end, each collector says, okay, I'm going to just reach an HTTP request to the target allocator, say, give me my jobs, so he doesn't have to explore. And then it's basically straightforward. And the great thing is you have also support for Prometheus CRDs. So if you're using pod monitor or service monitor, then you just use them, and by magic, the collector gets the metrics. So no need of touching the pipelines. So that's fantastic. So let's look at the numbers. So for that, I slightly changed the architecture. So stateful set with a target allocator enabled, a daemon set with just for logging perspective, so similar to what I showed you before. And then let's run the test. And here, in this test, keep in mind I enabled the Prometheus CRDs, so there's more metrics coming in. And let's take a check of the numbers. So in the top left, it's the CPU usage. We are about 200 MB core, so quite stable over time. So that's the soak test. And then on the memory utilizations, you can see on the metric side, we are getting we have like a increase of memory, but then if you use the right configuration of the garbage collector, it's reduced. But we have about max 800 megs consumed. And again, here I have tons of metrics enabled compared to the previous test. And then if you look at the target allocator, so because I'm splitting the work to the target allocator, let's have a look at the numbers. Here I'm consuming 10 millicore, almost nothing. And then in the memory, 60 megs. At the end, if I just sum all the resources between the target allocator and the collectors, I'm consuming less. So lesson learned, don't use one big collector. Do small things. Split it the work. And you will consume less resources, and it will be more stable over time. And the last point is, where should I process my logs? At the file receiver or at the processor? Well, I did some tests measuring the latency. There's no differences, no gain of time. I would just say that as a recommendation from the industry, try to filter at the source. So if you have different agents, do most of the work at the source. So then if you have the last mile collector will have less, or Fluent Bit will have less work to achieve, and it will be easier to parse. And then also to maintain the pipeline, because you have one collector, or one pipeline to do with the processing, then you will end up with a pipeline that is long like my arm, sorry. And it's going to be very hard to maintain. So having smaller ones is going to be much more easier to maintain over time. Conclusion, I would say, if you're dealing with logs, and only with logs, use Fluent Bit. Fluent Bit has been designed for edge devices. So it's going to be super fast, super efficient in resource usage. If you start to have the need of using metrics and you support cumulative backends, if you have more than one signal to deal with, collector will be the most efficient thing. And again, don't use the contrib version. It's not designed for production. Create a distro. So there is a tool called OCB, OpenTelemetry Collector Builder, where you can pick and choose the plugins that you need. You can go through your security scans, and that will be more recommended anyway. And otherwise, there's vendors like Dynatrace that provides collector distro that are secured and validated. It makes more sense for production usage. Yeah, small teaser for the YouTube channel. So I have plenty of content on Fluent Bit, the collector. This comparison is also out there on the channel. I also did a benchmark with Vector from the agent from Datadog. It's out there, so check it out. If you like it, like it. If you hate it, let me know, because with bad comments, you can only improve. So that's great to have bad comments as well. So check it out. It's available on YouTube. And if there are any questions, I will be super happy to answer to any of your questions.
Anyone?
I don't bite, don't worry.
Do you have any opinion/comment on the Grafana implementation of the OpenTelemetry? I can't remember its name right now.
Which one?
Grafana implementation of OpenTelemetry agent. I can't remember its name right now.
Yeah, so honestly, so they have their own structure of pipeline that is pretty much Grafana design. What I don't like is the fact that why should I have a different design experience? If I use a standard, I should use the same experience. So that's my feedback, because as an end user, the OpenTelemetry project has been designed to remove any vendor locked in your environment. If you rely on the standards, then at the end you can use whatever collector you want, and then the next day you say, hey, I don't want to use Grafana anymore, and you move on. And then using the standard, then you're not locked in. So you can either really easily transition and say, oh, I'm going to remove the output to Grafana, I'm going to place it to, I don't know, to Splunk or the Dynatrace, and that's going to be done in one line of change in the pipeline. If you're using their design pipeline, then yeah, you have to basically readapt the design experience based on the collector side. So that's my take. Again, I don't want to criticize what they're doing. They're an amazing company, and they're doing a lot of great things. Did I answer your question? Any other questions? Okay. Thank you.
Please give Henrik a round of applause.